How much of AI's frontier still lives inside the model itself? On August 13th, a new agent harness lifted Claude Opus 5 from 30.2% to 96.2% on the same reasoning test without changing the underlying model. The extra capability came from the working loop around it. Now here's the claim I'll stand behind. Size has stopped being the best map of intelligence. How a model can act, test, and try again now matters even more. That's today's lead. Also in today's episode, a hidden power contract, a tougher test for cancer remission, Apple crossing an AI border with Alibaba, and workers finding the old route back into jobs narrowing. Come with me, let's get into it. Any company paying a premium for the biggest model now has a problem. Its lead can shrink as soon as someone builds a better working loop around a smaller or cheaper system. So what has moved the frontier farther in just the last couple of days? Was it faster chips or cheaper models, or maybe better ways for the models to work? Well, let's start with speed. OpenAI previewed an Ultrafast service tier for GPT-5.6 Sol. It can produce up to 750 tokens per second. That is roughly 14 times its standard pace. The speed comes from Cerebras. Its processor uses an entire silicon wafer as one chip. That lets the models work to separate memory. So think of it as a cook with every ingredient on the counter right there. Most of the gain comes from cutting out the trips to the pantry. Cerebras says that it ran GPT-5.6 Sol through humanity's last exam, which is a set of 2,500 questions aimed mostly at expert-level knowledge. It says the run finished in 11 hours, compared with more than 3 days for another system at similar accuracy. Google pushed the price axis at the same time. Gemini 3.7 Flash arrived only 3 weeks after version 3.6, and Google says that it costs only half as much. Its coding scores also climbed sharply. On one Google internal test, it rose from about 34% to nearly 44%. Now that pace deserves a really clear look. Google is improving Flash and cutting its price. The company keeps releasing updates that look like progress, even though its promised Pro model keeps slipping until later. Fast version numbers don't necessarily substitute for the missing flagship, which is one of many reasons Google is lagging behind. Now, the biggest capability jump came from somewhere else entirely. Claude Opus 5 scored 30.2% on Arc AGI 3 when the model worked alone. This benchmark tests whether a system can reason through unfamiliar interactive problems rather than relying on pre-training. But if you give that same model the standard Claude code harness, it scores 96.2%. That's the same model, but a 66-point jump. The harness let Claude write its own parsers and simulators, run them, and throw away failed attempts and try again. So picture a mathematician covering the desk with scratch paper. The knowledge hasn't changed, but instead a model can now explore an idea, check it against the world, and keep the parts that work. That loop also helped Opus resolve 9 program bench tasks, including tasks based on SQLite and FFmpeg. That was more than 4 times the previous best number of resolved tasks. We saw the same basic effect on this benchmark in the July 18th edition of the Century Report. A different harness reorganized what an unchanged model could see and lifted its Arc AGI 3 public score from 13.33% to about 99%. More recently, news reports said that a neurosurgery resident without specialized math training used a 16-hour AI run to solve a conjecture that had stood for 2 decades. The report said the mathematician the theorem was named after verified that result. Now, model size is still important. Yes, it shapes what the system begins with. Yet the largest gain here came from letting one model work through a problem instead of forcing it to answer in one shot. And that changes who gets access to the frontier. A harness is cheaper to copy than a giant training run. It's portable. Now, that same loop has also lifted several other capable models tested with it, which means that any advantage only lasts a few weeks because other labs can quickly copy that advantage. So the limiting factor then, as we are seeing, is shifting elsewhere. Faster thinking does still need chips, electricity, and money underneath it. So the next issue is who initially supplies that foundation, and then later, who gets handed the bill for it. All right, that intelligence still runs on electricity, and Georgia's households could be exposed for decades if OpenAI's proposed campus subtly raises their power bills. So, who pays to connect a roughly $20 billion data center that may use 3 times as much electricity as Atlanta? Georgia Power and OpenAI know what their agreement says, but the public doesn't. The utility filed most of the 25-year contract under redaction. The grid upgrades needed for a campus this large costs money. If the company rate doesn't cover them, then other customers can end up carrying at least part of the cost. With the contract hidden, a household looking at its monthly bill has no way to check. The State Public Service Commission was preparing to object, and on Thursday, Georgia Power voluntarily extended the commission's review period. The utility said that it would respond by August 26th to an objection-seeking dismissal or revise the deal. 3 groups, the Natural Resources Defense Council, the Sierra Club, and the Southern Alliance for Clean Energy, asked the commission to reject the contract unless it includes basic protections. Their requests are really clear. Publish the terms, create one public rate category for very large power users instead of negotiating each deal in secret, and require a commission vote whenever a project exceeds 500 megawatts or a contract exceeds $1 billion. Now, the project can still proceed. The hidden arrangement part, that's what hit a wall. And that distinction is important. The AI build-out needs vast new power and quickly, and if a well-organized community refuses every project, then it can simply push that project toward a place with less money and less power to object. Campuses that build their own gas plants can also avoid the utility contract that gave Georgia regulators something to inspect. The better path is accountable construction. Let the public see the terms. Make the buyer cover the infrastructure it needs. Give every large project the same rules. 2 days before this delay, Anthropic agreed that consumers would not pay higher electricity prices because of the partnership's data center project. Georgia is now pushing toward the next step, public terms that let everyone verify where the cost goes. Once one commission builds that template, another can copy it. The secrecy becomes harder to defend, and the infrastructure becomes easier to build on terms that its neighbors can trust. All right, shifting over here. While Georgia asks what the public should be able to see in a power deal, people with relapsed multiple myeloma face a more personal version of that question. How deeply can doctors look before they call a cancer remission? The FDA's new approval of Zenbexus changes more than just treatment choice. Multiple myeloma attacks plasma cells inside bone marrow. The people who are covered by this specific approval have an advanced version of the disease and have already been through at least one earlier treatment. For years, doctors judged remission by asking whether standard blood and marrow tests could still find the cancer's fingerprint. Those tests can miss a tiny population of cells left behind, and a few surviving cells may give the disease a path back. The FDA has now granted accelerated approval to iberdomide, sold as Zenbexus, for certain patients with relapsed or refractory multiple myeloma. It is an oral medicine approved with an antibody and a steroid. This is an approved treatment rather than an early trial result that may take years to reach patients. 2 thresholds then moved at once. Zenbexus opens a new class of myeloma medicine. It also became the first U.S. drug approved using a much more sensitive measure of remission. That test can find a handful of cancer cells hiding among hundreds of thousands of healthy ones. So think of it as cleaning a dark room. The old test shows whether the floor looked clean from the doorway, but the new one turns on a brighter light and actually checks the corners. The brighter light then changes the bar for every drug that follows. Once regulators accept a finer test, future treatments face a harder problem. Did the cancer merely become harder to see, or did the therapy drive it beneath this much stricter threshold? Bristol Myers Squibb developed the medicine. Chief Medical Officer Christian Massachesi called Bristol the first company to bring a novel class of drugs to patients with multiple myeloma, opening venues for many more potential combinations. So the first company language benefits the company selling the drug, of course, but the second half carries the larger scientific point. Myeloma treatment advances by stacking different mechanisms until the cancer runs out of escape routes. Every new class adds more combinations that researchers can test. Yesterday's edition covered an experimental cell therapy that attacked myeloma through 2 targets at once. Today, doctors get another mechanism that they can use in actual care, measured against a stricter definition of success. We are able to focus more clearly on a narrower band than before, and now we can act on what that sharper view reveals. All right, so a finer medical test changes what can reach patients, while Apple is trying to reach iPhone owners across a border where the AI models that it uses elsewhere can't follow. Can a US company build its own model for China without becoming part of China's domestic AI stack? Over the past year, a policy on both sides has pushed toward separation. The US restricts what Chinese labs can buy, with questionable success, as we've covered here on the Century Report multiple times, while Beijing requires generative AI services to register before the public can use them. ChatGPT and its peers aren't available there. But Apple still sells phones there in what is one of the world's most competitive smartphone markets. It can't leave those devices without the generative features offered elsewhere. Its earlier plan relied on ready-made Chinese models, which would have left a central part of the product under someone else's control, which is not something that Apple does. Reuters reports that Apple has now developed a custom model for China and trained it with support from Alibaba. Reuters reports that Apple registered its on-device service with China's cyberspace regulator just last month, with a rollout expected within a few months through an iOS update. If that account holds, then Apple would become the first US company approved to offer its own model inside China. Alibaba's help is what makes the route possible. Apple gets more control over the experience on its devices. Alibaba provides the training support and local standing needed to clear Beijing's gate. Now, there's an important limit to what we know here. The report doesn't name the model's base architecture. We can't say that Apple built it on Alibaba's Qwen family. Qwen's existence shows that this is credible. Alibaba released open weights for a model with 2.4 trillion total parameters just yesterday. Companies around the world, including US firms, have already started building on that family. The technical foundation travels even when governments describe the two markets as separate stacks. Apple's exact lineage remains unconfirmed. The larger movement does not. A US company and a Chinese company have worked together on a model built for the market sitting behind the policy wall. Useful capability keeps finding the available channel. The border can change the route, the partner, and the paperwork, but it does not stop the flow. All right, as AI continues to move into everyday products, programmers, engineers, and financial analysts are finding it harder to use the old route back into jobs. Is this simply a weak job market, or is the pressure landing in a more specific place? A Richmond Fed brief tracked how quickly unemployed people can return to work. Since late 2022, that rate has fallen by roughly 13 percentage points for people with a strong connection to the labor force. These are the workers who usually bounce back the fastest. They tend to have steady work histories and keep looking. For people with a looser connection to work, the decline was only about 2 points. And that split is actually unusual. During the Great Recession, both groups were hit hard at the same time. The people most affected right now are those who would normally have the easiest path back to work. The sharpest drops appear in occupations with high AI exposure: programmers, financial analysts, and engineers. The pattern itself can't explain why every individual remained unemployed, but it does show that the pressure isn't spread evenly across the economy. The people taking the first hit often did exactly what the old system asked. They gained credentials, they entered skilled professions, and they built steady work histories. Now the knowledge that once protected their place is becoming cheaper and easier to access. Now, the UK has actually launched one early response in northwest England. Up to 70 people between 16 and 21 will attend a 3-week AI bootcamp. It leads directly toward apprenticeships with BAE Systems and Heinz. Participants will train on systems that the employers already use, such as systems from Microsoft, OpenAI, and Anthropic. The need is urgent. The ONS estimates that more than 1 million people aged 16 to 24 in the UK are now outside work, education, or training. That is the first time that this estimate has crossed 1 million since 2013. Boca Klein-Tesselink of King's College London doubts that 3 weeks can really build durable skills, and he's probably right. 3 weeks won't answer a labor shift this large, but it can still test a better structure. The old education model treated skills like a tank that you filled just once and then drew from for your entire career. AI is making that supply lose value much faster. Training now has to work more like running water. Constantly running water, continuous, close to the job, and available wherever the work happens to change. The first pilot is small and thin. Its most important feature, though, is the direct link between learning and an employer. A 16-year-old without an established credential gets access to the same class of systems reshaping professional work. Now, what we get to watch next is whether that link becomes permanent in this new and, I think, very temporary jobs economy. Short training can become repeated training. Apprenticeships can keep adapting. Expertise can spread beyond the people who already passed through an expensive gate. The workers losing the old route deserve more than just a boot camp, of course, but the pilot still matters because it begins testing the shape of a new and a better one. All right, let's close it out for today. So does bigger still win? Sometimes, maybe. A wafer-sized processor can run a frontier model at astonishing speed. A data center can draw more electricity than a whole major city. A 2.4 trillion parameter model can become shared infrastructure across borders. So size still counts. It just no longer tells us where the decisive capability lives. Claude's largest gain came from a loop that let the same model write, test, fail, and try again. That loop is portable. It can spread much faster than the training run that produced the model. As that capability spreads, the hard constraints move into view. George's question is who pays for the power and whether the public can inspect the deal. Myeloma treatment now faces a finer test of how completely a medicine actually clears the cancer. Apple's partnership with Alibaba shows commercial demand routing across a border built to separate technical stacks. Workers are discovering that one credential can no longer carry an entire career. These are the signs of growth pushing against the next layer of limits. And that is hopeful because these limits are things that we can work on, we can question, we can raise above. We can publish power contracts. We can measure remission more precisely. We can share technical foundations across borders. We can build learning that continues after someone leaves school. We can challenge the entire extractive system itself. Across these stories, then, the focus is shifting from sheer scale to connection. Intelligence working with code, infrastructure working with a community, medicines working in combination, and people learning alongside systems that keep improving. The largest thing in the room no longer gets to define the frontier by itself. The future belongs to what can connect, adapt, and spread. See you tomorrow.